All right, folks. So as Chris said, I'm going to be talking about demand sensing. And a lot of this is going to be specific to the era of COVID. So what happened recently is that with the spread of COVID, we saw a huge disruption in supply chains. And we were really faced with these new unprecedented challenges with how do we forecast demand in this kind of situation. Now, the reason it becomes so challenging to forecast demand is because the traditional time series models that are typically underlying these forecasts, they rely only on historical data. And so they're not really accurate in response to COVID demand shifts because these models have never seen something that's so disruptive before. So this very high demand volatility made it very challenging to be able to take any kind of corrective actions in a timely manner. And I'm sure we all remember, the initial stages in early March where grocery stores had a lot of empty shelves because of stockpiling. So moving forward, we expect that there's going to be a lot of increased disruption, and it's going to be coming in from a variety of different sources. This can be related not just to the pandemic and potential relapse, but also potentially civil unrest, recession, climate change, and so on. So as the next disruption hits, we need novel approaches that are going to help us navigate and predict the impact on demand, on consumer preference, and on behavior. So we start this by looking for what's the desired level of forecasting, the time horizon, and the geographic granularity. So typically this will be down at a SKU and store location level. And we can embed data from a variety of different sources and integrate this with client historical data. So our modeling approach allows us to compute demand from multiple models, and finally we can display them in some interactive visualizations. The key outcomes here are to drive accurate demand insights, to lower inventories, and to optimize operations. So COVID has been driving a lot of lasting changes in consumer behavior. We saw a lot of rapidly evolving government guidance, changing policies, and all of these impacted retailers and consumer goods companies. So for example, we saw online food sales went up by 100%, and we saw a decrease in discretionary spending. This could be reflected by reduced clothing spend and furniture sales. We saw grocery sales by themselves went up by 14%. And then we also saw home office supplies that saw an increase in sales by up to 3 to 4%. So all of these disruptions meant that there was a change in the sales channels, moving away from in-store sales and more towards curbside pickup. We also saw a huge demand for digital acceleration amongst retailers and CPG companies. So what we're doing now is to combine internal and external data, and we take known demand signals. We leverage AI and machine learning models to deliver some persona-based insights. And I'll go into a little bit more detail about the models, but here what I want you to take away is that we can have different personas use the insights in different ways. So for example, a demand planner, they can use our demand forecasting deep learning models to identify any supply chain disruption in near real time. A merchandise planner can predict sales for given product categories, for channels and locations. And then someone from store operations might be more interested in consumer movement patterns or footfall traffic in each store. So to that end, we've built a curated data lake and a series of analytical and AI accelerators that can be leveraged as either independent insights or they can augment demand forecasting models. So starting with our data accelerators, we have COVID statistics and insights. We have policies and regulations such as government and state actions. We have socioeconomic data, and this can include unemployment, location, weather data. We also have news and social media data. And then we also bring in the client data here. So this can be point of sale, this can be shipments, it can depend on the use case. Clients can bring in promotional calendar information, and of course, we take in their product and customer master tables. But along with these data accelerators, we have a series of derived signals, and each of these have an underlying deep learning model themselves. So for example, we have something called the resurgence index, and this is a predictive measure of where and when the next wave of the pandemic will hit. I'll do a deep dive into the disruption index and the consumer safety index next. But basically, these indexes feed into AI models, and that's how we have this COVID decision support system that can provide real-time insights at a hyper-local level. So let's take a look at a demo and see these insights in action. So here, what I'm showing is how we use deep learning and time series models to create something called the disruption recovery index. And this is predicting volatility in local economic activities. So the disruption recovery index leverages localized information of COVID conditions along with market and macroeconomic data, and it tracks how consumer behavior is tracking to the disease conditions. We also have a mobility index, and this is a predictive measure of how far on average residents are traveling, for example, to and from work or retail stores or grocery stores. And we can see how various lockdowns in different states affected mobility over time. We can also look at, for example, macroeconomic data. And this here is showing unemployment data. Again, you can see how this is tracking with decreases in discretionary spending. Did it have an impact on sales for retailers, and so on. Then we bring in policy and government actions. So this can have, at a state level, what were things like stay-at-home orders, or was there a mandatory quarantine in place for any of these states? We also have a core Nlp engine, and this extracts and processes text data. This is coming from news, from blog posts, from online discussions, and it basically has an event trigger model, which can be configured for any kind of event of interest. It can be business closures, again, anything to do with factories, colleges, restaurants, and so on. So going back to the disruption index, let's have a deep dive into it. Okay, so, all right. So with the disruption index, what we're interested in here is to measure the risk of doing business at a county level. And the premise here is that consumer demand is very strongly influenced by local response to COVID. So we built this index with the idea that it represents an economic expression of the behavior of financial actions taken by consumers. So we can analyze external data for economic volatility. We take in COVID information, we have market data, public health data, and we built a deep learning model using Python and R, and this gives a forward-looking view of economic disruption. So this index is used as an input to demand forecasts, and this does especially well in volatile situations. We built this composite volatility measure that uses market and economic data. And then we also know that consumers are very keenly aware of the global pandemic numbers. So this in turn has an impact on our composite volatility measure, and it tracks with a very high correlation to the global case numbers. So in other words, what this is doing is it's describing how consumers are reacting to uncertainty in financial conditions. Local news and events are also playing an important role in consumer behavior, especially the caseloads in the counties where they live. So our forecasting engine is basically taking an LSTM model that also takes in all of the location and causality information along with local COVID cases and that composite volatility measure, and predicts that forward-looking disruption down at this very granular location level. And so these forecasts in turn can then be used by CPG or retail companies to assess supply replenishment risk based on these localized case densities. So for example, each county here will have its own unique signature. Each one will closely reflect that local caseload and the economic volatility of that location. And that risk level is relative, showing where each county lies on a scale of low risk to severe risk, allow retailers to decide where should we reopen stores next, where should we allocate inventory in anticipation of reopening. Okay, so let's move on to the second index. This one is the Consumer Safety Index. And here, what we do is we're identifying consumer behavior by using social media data. So for example, even if a retail store is open, what is the probability that consumers will feel safe to go there? And the benefit of using social media data here is that it does not rely on any historical data. And as we saw, the existing models did not really handle the COVID scenario well because there was no examples, no historical examples of such an event happening. So the consumer safety sentiment is real time. It can be different sources of disruption, and it can be injected into other models and forecasts to enhance existing model accuracy. So we load social media data and sub-select and identify posts of interest. This is done using a nearest neighbor algorithm. We use an NLP transfer learning algorithm to identify the probability of any post expressing various sentiments. And then we can view this real time. It can have hourly, daily, or weekly updates. What we're basically doing here is we're calculating the conditional probabilities of whether the post expresses a fear sentiment. And we can do this across various dimensions. So for example, we can calculate what is the probability of a COVID post being fearful, or if we wanted to go further, we are then saying, can we calculate the probability of a COVID post about going to a retail store from a California user being fearful? So let's take a look at some results. And here, what we're seeing is the daily percent growth in cases in the background in gray, and the consumer safety sentiment applied to the groceries dimension in blue to the scale on the right. So a higher scale here means that consumers are feeling safer. So we start off in the first and second week of February. There's a little bit of uncertainty around the virus. We start with, people saying that there's maybe some upsides to this. For example, Costco was empty, which never happens. And then we kind of see that maybe people are not taking it that seriously yet in the first week of February, where only a few people are wearing masks. And then as we get towards the end of February and the beginning of March, this is when we started seeing the panic buying with store shelves being bare because of stockpiling. Then in March, we start seeing some examples of fatigue. So now people really want things to return to normal. They want their free samples back. And in April, we start entering this new normal where families have masks from their local economy. They're preparing to go out. And really towards May, we start seeing very low levels of fear. So they're packed stores, but very low mask wearing. And this can then act as a leading indicator to resurgence. So this index can be used to determine things like when will people be willing to go to stores again? What's the likelihood of shoppers returning to malls? We can also see how are shoppers viewing online shopping versus a gig economy grocery delivery app and going in-store. And this can allow CPG and retailers to identify locations with the highest and lowest risk and then redistribute stock based on expected future demand. Okay, so how do we use these indexes? Our solution, this is deployed on IBM Cloud. It combines these internal and external data sets, structured and unstructured data sources, goes through a data virtualization layer, and then we use our Accelerator AI models to produce these short and long range forecasts. So here I'm going to talk about an approach that we took where we did some time segmentation followed by ensembling a time series machine learning model with a milestone model. And basically what this does is it combines the trends and consumption uplift to create a comprehensive view of demand in the new normal. So what do I mean by a segmented time series? We're looking at some historical point of sales data, and we can take this data and segment out things like pre-COVID point of sale data. We can have the panic buying stage, the social distancing stage, and the new normal. So in the panic buying stage, we saw consumption really peak as consumers were stockpiling in anticipation of a prolonged lockdown. And this behavior happened simultaneously across states, regardless of the number of cases or state actions implemented. We then entered the social distancing stage, and the length of this period differs state to state. During this period, we saw point of sale being significantly affected by social distancing factors. For example, kids are not going to school and there's an increased consumption at home. And finally, if we look at the new normal stage, this is really where we're seeing those long-lasting effects. What's going to continue into the new normal, even after social distancing measures are lifted? So we take these time segments and we create an ensemble model that encompasses a milestone model, which analyzes these consumption patterns during each phase, and a time series machine learning model. So the milestone model is analyzing consumption patterns during panic buying and social distancing. For example, this can be state-specific COVID milestones, such as peaks of infections, peak of deaths, expected consumption normalization. We can also add in things like percent growth during the peak period, which determines how fast consumption will then decline. Of consumption, which can also be added into this milestone model. So this allows us to very quickly react to demand spikes or to changing trends and accurately estimate increased consumption and any converging trends towards the new normal. And it's very easy to integrate with the machine learning model. So the next component is this time series machine learning model. Here we can incorporate seasonality, trends, we can add variables such as effects from promotions, pricing, holiday calendars, and so on. And this component model, based off of generalized additive models, splits time series into multiple periods. It allows us to distinguish between seasonality and one-off events. And this model allows us to also decompose the impact of external regressors from the overall time series. And we have the ability to add regularization to prevent overfitting. So this combined model then leverages known seasonality trends of pre-COVID historical data and the event-based milestones, providing a comprehensive view of consumption and forecasting demand in the new normal.
Pardon me, Kriti, we just have a couple minutes here. I just want to give you a quick warning there. My apologies.
Okay. Yeah, thanks. So I'll quickly run through this, but here's an example of another model that we have from IBM Research, and this is a multi-factor attentional neural network. In this forecasting model, we're adding interpretability by adding context-based importance weighting to these external factors. Each factor is processed by its own expert neural network, and this extracts the most useful features from the data set. So, for example, it can be features like the ratio of average weekly temperature last week versus this week from a weather data set. The network will then determine the contribution of each factor based on the context. So, for example, weather features play a less important role when there's a price promotion event that's happening. And the contributions of each expert network can then be added to create the final prediction. So in this result on the right, we can see that for the commodity at store 21, we had multiple primary factors feeding into the model. This included event data, social media data, weather data. And for week 9, we saw an increase in consumption. The forecast from the neural network predicted this increase, but a traditional exponential smoothing model did not. We're also able to pick out that the significant primary driver for increased consumption is likely to be weather. And we can break down what the specific weather factors are. So our forecasting models, they're scalable. We can work with hundreds of gigabytes to terabytes. We've built the set of accelerator algorithms. It goes everywhere from traditional time series to advanced deep learning methods. We have data transformers that can process the data, prepare the data for each algorithm, run hyperparameter optimization, and integrate it with unit tests. Finally, just quickly from an enterprise perspective, because it wouldn't be IBM if I didn't talk about it from the enterprise perspective, but our models are all integrated and embedded into established client tools, demand planning systems such as IBM Planning Analytics and SAP Integrated Business Planning. So demand planners can really take advantage of this. These on-demand forecasts can be generated directly in their workspace. It's all pre-configured solutions that link together the forecasting models, the data sets, the indexes that I talked about, all combined with the traditional demand planning cycle to really drive forecast accuracy. This work was done by a lot of different teams, encompassing the different models for indexes, the research models, forecasting models, model infrastructure, and enterprise platform support. So I just want to give a quick shout out to my team as well. And I'm happy to answer any questions.
Thank you, Kriti, very much for that excellent presentation. Let's see here. We do have a couple of questions. Do you have and can share information about the current data situation now that we're in a second wave of cases? Do you see signals of another panic buy period?
Yeah, that's a really good question. So we are seeing we are seeing a lot of different increases in cases from our resurgence index. That's specifically to predict where and when the wave is going to be increasing or decreasing. We see that reflected in the disruption index as well, because that's a predictive forward-looking measure of the economic volatility. In terms of the panic buying, what we've noticed is that people have settled into a general new normal stage, and we're not actually seeing the types of peaks in consumption that we had seen before. And from a client perspective and CPG and retail perspective, clients have also become a little bit more sophisticated with their forecasting methods, for example, with the methods that we provide. And so the forecasting models and the planning cycles are more on a continuous basis, which allows them to react faster.